Hello everyone, I am Ramesh KS. Uh, Today we will learn decimal numbers and their binary, octal and hexadecimal equivalents. So I will draw today one chart related to this. So let us write decimal numbers decimal wait sometime decimal numbers and their binary comma octal hexadecimal equivalents. So in this, I am going to draw a chart. Give me some time. Here the first one is decimal. The next one binary, octal, and last hexadecimal. In this, the first one is decimal. So I will write the decimal numbers 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, up to 15. So because of in order to match with hexadecimal, I used to take decimal numbers till 15. Okay. Again, binary numbers up to 15. So how I can write these binary numbers? If you write like this, see, if you write like this 0, 0, 0, 0, so it's very difficult to write all numbers. So I will give you one technique to you. So you can write here 8 zeros: 1, 2, 3, 4, 5, 6, 7, 8. So 8 zeros and 8 ones: 1, 2, 3, 4, 5, 6, 7, 8. So 8 zeros and 8 ones. Again I am taking here, 4 zeros and 4 ones. 4 zeros and 4 ones. 1, 2, 3, 4. Now ones, 4 ones. 1, 2, 3, 4. Again 4 zeros, 4 ones. 1, 2, 3, 4. Now 1, 2, 3, 4. So 4 zeros, 4 ones finished. Now, so the next thing is two zeros, two ones. Okay, so here I am taking 0. Let us take down. Okay, two zeros, two ones, two zeros, two ones, again two zeros, two ones, again two zeros, two ones, two zeros, two ones. Okay, now the final row is 0 1 0 1. Okay, now so now I am taking here 1. Okay, not 1, 0 1 0. Okay, 0 1 0 1 0 1 0 1 0 1 0 1 0 1, finally 0 1. See how easy we can write like this, right? See, if you write like this 0 0 0 0 0 0 1 0 0 1 0, it's very difficult to write all numbers, all binary numbers. If you follow this, it is very easy to accommodate uh, all decimal equivalents. Okay, so this is about binary numbers for these decimal numbers. Okay, now I am moving into octal. Okay, so all of you know that this binary equivalent octal number is 0. Okay, 0, this 1 2 3 4 5 6 7. Now tell me, this is for 8 or 9? There is no 8 and 9 for octal numbers, right? So now this 1000 for 10. Okay, na? So 10, 11, 12, 13, 14, 15, 16, 17. So that means here this 1000 is a binary number. This binary number equivalent decimal number is what? 8. Okay, na? 8. And this binary number equivalent octal number is what? 10. So we will test this. Okay, next after completion of this table we will test this, so you can understand clearly. Okay, so this is about octal numbers. We cannot include here 8 and 9 because up to 7 only we are including octal numbers. So now the hexadecimal number, we are moving into the hexadecimal number. So up to F we can write. Okay, 0 1 0 1 2 3 4 5 6 7 8 9. For 10 A, for 11 B, for 12 C, for 13 D, for 14 E, for 15 F. This you need to take this. Okay. Okay, this is about decimal numbers and their binary and octal hexadecimal equivalents. Okay, na? Let us save this. now now I wanted to test this chart with the help of converting from decimal system to binary or octal or hexadecimal. So now let us understand. They may give us this decimal number. Let us take this 10. So steps for converting decimal to binary. Okay now. So the first question is converting decimal system to binary number system. Converting decimal system to binary number. So now the first step is so divide the decimal number by 2. Divide the decimal number by 2. This is the first step. Okay now step 2, again second step, record the remainder from step 1 and as the rightmost digit and quotient. Also record the quotient. Okay now record the remainder from step 2 and quotient. Okay, this is the step 2. So now the step 3, divide the quotient of the dividend number by the new base. Okay, note down the remainder as the next digit. Record the remainder from the step 1 and quotient. Again repeat the step 1 and step 2 until the quotient becomes 0. Repeat the step 1 and step 2. Repeat the step 1 and step 2 until quotient becomes 0. So here you can understand the quotient means all of you know it. This is what step 1. This is step 1. This is step 2. This is step 3. Okay now, step 1 and step 2. So repeat the step 1 and step 2 until quotient becomes 0. First we have to divide the given number by 2. Record the remainder and quotient. We can say remainder and quotient, not needed from step 1 and quotient. You can write record the remainder and quotient. Finally repeat the step 1 and step 2 until quotient becomes 0. So now I will take this number. Okay na? I will take this number 10. So I will test this number whether this number is equivalent to this number or not. Okay na? If this number is equivalent to this number, our approach is correct. Okay, so let us take I am taking 10 here. 10. So this is which number? It is decimal number. What is the base of this number? 2. So in earlier classes we discussed the base of the decimal number system, that is 2. Okay now. So so what I am doing is I will do, I will divide, this number by 2. Okay na? Wait some time, give some time. So now, so which number I am going to divide? 2. Okay, so 2 here, 2. I am going to divide by 2. So now, so 2 5 ja 10, right? So it will divisible by 5. So the 5 is the quotient now. Okay. So now what is the remainder whenever if you divide with this 5? 2 into 5 10, right? So the quotient is, sorry, the remainder is remainder is 0, because so you know that in school days we learned this division. Okay, let us write, suppose let's take one example, 2 here, 10. Okay na, here again 2 5 ja 10. Okay, now this is what? 0. So this is what? Remainder. This is what? Remainder. This is what? Quotient. That's what I am placing here. Okay, all have understood? So now let us move on. Again I am dividing, suppose divide the decimal number, this is the decimal number, I am dividing with the 2. Again record the remainder and quotient. So this is the remainder I have recorded and quotient. Again what is the step 3? Repeat step 1 and step 2 until quotient becomes 0. So I am repeating the step 2 again. Now I am repeating the step 2. So again I am dividing with the 2. So once after division of 2, so here so 2 ja, correct? 2 times it will occur. What is the remainder? 1, right? Remainder 1. Okay, so remainder 1. Now again divide this number by 2, because until quotient becomes 0 we have to divide, right? That's why. So again I am dividing with 2. Again I am dividing with 2. So here 2 1 ja 2, correct? 2 1 times. So what is the remainder? So the remainder is 0. Okay, so the remainder is 0. So quotient becomes 0 now. How quotient becomes 0? Now I am taking here, if I divide with this 2, what happens? So quotient becomes 0 now. Okay, now this is the quotient. So this is the quotient. This becomes 0 now. So once after it becomes 0, so what is our next process? That means remainder of 1 becomes 0. Okay, that means here remainder is 0. Remainder is 0. Sorry, remainder is 1. Remainder is 1 in this. Correct? So how it becomes 1? All of you know it, right? See, I am taking here 2. This is 1. So 2 into 0, 2 into 0, 0. So what is the remainder here? 1. What is the quotient here? 0. So until quotient becomes 0, we are repeated the step 1 and step 2, right? So that's what here remainder 1. Here remainder 1 and quotient is 0. Now the final value is, how we are going to find the final value? How I am going to find the final value? So from bottom to up. From bottom to up. So in this direction we have to find the binary value. So what is the value? 1 0 1 0. So now the answer is 10. So 10 is the decimal number. So for this is the decimal number. Equivalent binary number is 1010. So did you observe in this? 10 is a binary, this is a decimal number, the equivalent binary number is 1010. We proved it, right? So this is what converting from decimal system to binary number. So what did you understand by this? So the first step is we divided with the 2. We divided with the 2, divide the decimal number, this is a decimal number, by 2. Record the remainder and quotient. Finally repeat the step 1 and step 2. Again we are repeated the first step 1 and step 2 until this quotient, this is a quotient, it becomes 0. Until quotient becomes 0. Finally we will get the remainders from bottom to up. From bottom to up, not bottom to up, means here in this direction. In this direction, in this direction. Bottom to up in this direction. In this direction, I am taking the values 1010, not 0101, 1010. Bottom to up, we have to consider the binary elements. So finally, the output is like this. So that means 10 is the decimal number. It is converted as binary number. So 10 decimal number, that equivalent binary number is 1010. So now you can test this element and this element as well. So you can get the correct output. Okay. Okay. Let us try. Let us try this number 11 or 12. You can try 12. Okay. Can we try? Yes. Here I am writing. Here I am writing 12. Okay. So now in this, so what is the step 1 now? Divide the decimal number by 2, right? Now 2, how many times it will multiply? 2 6 ja 12, right? So it is divisible by 6. 6. I am writing 6 here. 6. That means 6 into 2 into 6 is 12. So 12. Now what is the remainder? If I divisible by 6, what is the remainder? Remainder is 0. All of you know it. So now again, so which number we can multiply or we can divisible with this? So we are divisible, we are dividing with the 2, right? Now I am writing 2 here. Now I am writing 2 here. So 2 3 just 6, correct? So here I am taking 3. 3 is divisible by 6. So now what is the remainder? Remainder is 0. Remainder is 0. Remainder is 0. Now again I am going to repeat the step 1 and step 2 until quotient becomes 0. Okay na? So again I am taking 2 here, dividing with the 2 the decimal number 3. Okay, divide the decimal number. So what is the decimal number here now? 3. So again I am dividing 2 1 ja 2. So what is the remainder now? Remainder is 1. Remainder 1. Again until quotient becomes 0 we have to repeat the steps, right? Again I am taking here 2 0 0. Now the remainder is 1. So until quotient becomes 0 we have to repeat the step 1 and step 2. So what is the step 1? Divide the given the decimal number by 2. Yes, we have divided with the decimal number. Again we record the remainder from the step 1 and quotient. We recorded the remainder here and quotient as well. Again we are repeated again and again until quotient. This is the quotient now 0. Until quotient becomes 0. So finally we got the quotient as 0. We stopped it. The process is stopped. So once after completion, that means the process stopped, right? So now we are considering the output from bottom to up. So 1 1 0 0. So what is the output? 1 1 0 0. For 12 1 1 0 0. 1 1 0 0. So this is the output. That means this is the decimal number. See here 12. 12 binary equivalent is 12 is the decimal number. The binary equivalent of 12 is 1 1 0 0. Correct? See 1 1 0 0. So you can test this 13 and 14 and 15. You will get the correct binary equivalence. Correct binary equivalence. So let us all of you, I am requesting you, please practice this conversions at home. Come back to the next class. Okay now? So next in further sessions we will discuss how we are converting from decimal to octal and decimal to hexadecimal we will discuss. Okay now? So I am revising converting from decimal to binary number system. The steps include this. So divide the decimal number by 2. We have divided the decimal number by 2. Finally we recorded the remainder and quotients again, and we repeated the step 1 and step 2 until the quotient becomes 0. This is a quotient. This is a quotient. It becomes 0. We repeated the steps. So finally we recorded how we are placing the output from bottom to up. From bottom to up. So from bottom to up, see 1 0 1 0. So this is 10 is a decimal number. The binary equivalent of the decimal number is 1 0 1 0. So binary equivalent of this decimal number 12 is 1 1 0 0. We proved it here 1 1 0 0. So try at home 13 and 14 and 15. Okay na? And 11 as well. So you will get these outputs, binary equivalents. Okay. So further, so tomorrow or day after tomorrow we will discuss this decimal to octal number conversion as well decimal to hexadecimal number conversion. Okay na? Okay. Okay. Thank you everyone.